Welcome to Sinumeric Live, application technology made simple. Our video series with the aim of presenting Sinumeric related topics in a practical and time-saving way. Today we're going to address a topic that I as a Sinumeric Operate user have not yet had anything to do with, the topic of robotics. I've invited my colleague Umberto Neuwirth to help me with this. Hello Umberto.
Hello Tobias. Yes, we just want to show how the interaction of a machine tool with a CNC-controlled robot works. There are now countless robotics applications in production, and today we're going to take a look at the machine tool in particular.
As I've heard, actual robot handling with Sinumeric is very simple, intuitive, and above all, process reliable. So please explain to us what we have here.
Of course, here we are in front of a machine tool model equipped with our high-end Sinumeric 1 controller. This machine tool model is loaded and unloaded by a robot. The entire automation solution is operated via Sinumeric Operate and the machine control panel.
In other words, a working environment that I as a Sinumeric Operate user know very well.
Exactly, and robot solutions on the machine tool are becoming increasingly popular, to reduce idle times, for example. So, of course, it's then a great advantage if you as a machine tool operator can apply your existing Sinumeric knowledge.
Yes, I agree. And at the same time, I think robot solutions can take the heavy physical work off our hands. So what does that look like in practice?
Well, Sinumeric-controlled robots can, of course, carry out simple loading processes of clamping devices, workpieces, or tools, but can also be used for activities such as deburring. This relieves the machine tool of rather simple tasks because the robot can also perform these activities well. This is much more efficient, and we use such a solution at the motor plant in Bad Neustadt to deburr the workpieces there.
I have to admit that a robot like this, especially if like me you've never had anything to do with it before, seems relatively complex. I'm counting 1, 2, 3, 4, 5, 6 axes. And then there's the multi-axis design of the machine tool.
Right, but it isn't really that complicated. With Run My Robot Direct Control, the robot mechanics are controlled directly from Sinumeric. This means that we didn't install our own robot control system here, but Sinumeric takes care of everything. This is extremely user and operator friendly and optimally exploits the full potential of the robot and machine tool.
Okay, so that sounds quite straightforward to begin with, but what exactly does that now mean for me?
Well, you remain in your familiar Sinumeric Operate environment, and as you know from various machine tools, you can then operate and program each robot mechanism in the same way. So you don't have to learn any new programming language for the robots. You can implement this yourself with your existing Sinumeric knowledge. So you don't need a new robot programmer. Standardization is the keyword here.
Very good keyword. Again, for my understanding, to operate a Sinumeric-controlled robot, I don't need any special knowledge, I don't have to learn a new programming language and so on. My previous knowledge as a Sinumeric Operate user is even sufficient for robot programming. This means we simply expand the robot to include another channel of Sinumeric.
Exactly. As you are saying, this is also implemented applying the multi-channel principle. You know this from turning machines with multiple tool carriers. Here, the 5-axis machine tool is integrated in the first channel and the robot in the second one, or others with its 6 axes. To control this, simply use the normal axis selection panel on the machine control panel in the second channel, for example. You want to give it a try?
Sure, I'll give it a try now. The first axis? Yes. Then we also have the second axis. Okay. The third axis.
Exactly.
Well, my first impression, so far so good. But I have to say it takes me a little longer to traverse the axes to where I want my workpiece to be.
Right. And that's exactly why a transformation comes into play here. This transformation converts the robot's rotary axes into Cartesian XYZ coordinates.
Okay.
You know that from the coordinate cube. Now imagine the coordinate cube at the tip of the gripper. You could now traverse this by selecting TCS on the machine control panel. I'll move the robot to the starting position for you.
Yeah.
And then you can get started and try out your TCS.
Okay. Nice. Then I basically select the TCS here, and I can move the axes. And how do I store my position that I want to reach, or have reached, or still want to reach? How do I store it?
To do this, we use the teach-in function in the MDA or auto operating mode. And with this, you can then save the current robot pose. That's the position information XY and the orientation information ABC at the same time. Do you want to do that for two positions?
Pose was a new word now. That's not short for position, it means more, as I gathered. Pose would be a position with even more information.
Exactly, with the orientation positions.
With the orientation functions, exactly. Right, let's save the whole thing, MDA, and the teach-in program. And here, in the vertical soft key bar, the teach-in position opens in the top position where it belongs. This means that the first position has been taught. Now we're traversing.
Preferably a little forward and up.
Yes, so that we can see it nicely. Fine. Now you'd have to teach in a position again, and then we have both positions. Okay, now I've seen that you can operate the SINUMERIK controlled robot using the machine control panel in the same way as a machine tool. Does the robot behave in the same way in programming?
Of course, you program the robot in the same way as you program your machine tool. The 0, the 1. In other words, G-code. And there are two variants to get from a point A to a point B. One would be point-to-point, or PTP for short. The robot tries to reach the next pose with the highest possible velocity in the individual axes. This is used, for example, to pre-position the robot.
Nice. Let's just give it a try. We're now traversing. You say G0, G1. We simply take the path command G1, and then of course we need a feed rate. Let's take F6000. That's a pretty good value. And then enter point to point, or P to P, and that's really all there is to it. We simply add the coordinates to these three commands. That should be it, really. Start of the program, press reset, so that everything's reset to start. And with that, you should actually be able to traverse it now, okay? Yes.
You see a very fast movement. The other variant would be continuous path, or CP for short. The robot tries to traverse as smoothly as possible on a constant path. For example, a straight path to remove a workpiece from a clamping device.
Okay, in principle, we've already entered everything, so we just need to replace PTP with CP.
Exactly.
It's really not complicated. Reset again, and now we're traversing with this variant. Aha. You can see here that it's traveling straight from point to point on a constant path. What other SINUMERIK options can be used to create a program that's as modular as possible?
For example, there are the work offsets that we set where we want to pick up workpieces with the robot. Starting from a 0 point, we can then program the retract movement without ever having actually approached the positions with the robot.
Okay, but I can use this program again for similar workpieces, right? For example, if you adjust the pickup point, in other words the 0 point, accordingly. In principle, that would be the same as multiple clamping on a milling machine with a large table.
Exactly. In the end, the robot movements during loading and unloading are always similar. You can therefore simply put together the motion sequence with subroutines until you have created your standardized loading and unloading program. So let's take a look at what the whole thing actually looks like. I've prepared a few steps for you. At first, we'd pre-position the robot at the point where we want to pick up the workpiece. Then set the 0 point. And starting from this 0 point, you then program retracting. Let's just try that now.
Yeah, of course.
So now we're at the robot cell. You see, the robot cell door is open.
Right.
However, you have a handheld device in your hand with an acknowledgement button. If you press this button, you can slowly traverse the robot.
Just like with a machine tool.
Now let's move the robot to the workpiece pickup position.
Program teach in, position teach in, and it's there.
Great! In the next step, you must then move to the pickup point and then set your 0 point, e.g. G510.
Okay, that means we select the Z-axis in this case, for example. As with the machine tool, this can also be superimposed nicely with rapid traverse. Then we move the whole thing forward a little with X. And in Y, that doesn't look too bad at all. Again in X, a little ahead. Yes, I think we could do a little more in Y. So, we're quite well positioned.
Very good. Now we set the 0 point G510.
Yes, this is done as usual in jog with TSM, work offset G510, which is exactly the same as for the machine tool. It's then also fixed with cycle start or selected. I assume you'd now have to set the work offset to 0. This is the same as with the milling machine, for example. So, all back to 0 now.
And now we can program the retract movement based on this. By the way, with M20 you close the gripper, and with the M function M21 you can open it.
Yes, then I'd say we enter M20 for closing the gripper at the appropriate point. So in my opinion, we'd have to move up first. Z2 for the second channel would be 20 millimeters. I think that should be enough. And then again, X2 equals 100.
Excellent.
And that's it actually, because we did the teach-in, we set the 0 point, we specified the gripper position, and retracted.
Exactly. And placing in the machine tool then works in the same way. You can use these programs again and again without having to reprogram anything. All you have to do is move your 0 point, just like with multiple clamping.
You feel right at home on the machine tool. It's the same device, the same hardware, the same procedure, and therefore half as bad as initially thought.
Right. Now let's have a look at what you've programmed.
Exactly. That was half as bad as it sounded at first. And since we're working at G-code level, I'm sure that all high-level language elements for modular program design and other functionality, such as frames, can be used, right?
That's right. Programs and robot movements can be reused easily. As an NC programmer, you can enter new workpieces with minimal effort, and you don't need a robotics expert for this. What we need now is a way to synchronize the channels of the machine tool with those of the robot. Do you have any idea?
Well, I'd suggest our tried and tested weight markers.
That would be my suggestion as well. Weight markers are actually the most practical solution for coordination between robots and machine tools. This means that there is no need to resort to error-prone I/O signals, and as an application engineer, you always have an overview of the entire process. And by the way, this is what the process looks like in its entirety. A so-called job consisting of channel 1 and channel 2 is selected. The robot starts and begins to pick up the workpiece, takes it to the machine tool, loads it, and then the machining process is started there. As long as the robot has nothing else to do, it can, of course, perform activities such as deburring. And as soon as the machining process in the machine tool has been completed, the robot can remove and store the workpiece. Then the whole procedure can start all over again.
Yes, so how do I get such a robot solution?
Well, Run My Robot Direct Control can be integrated into the machine by the machine manufacturer right from the start, or afterwards, for example, by a system integrator. The best way to do this is to contact your Siemens representative or the machine manufacturer directly.
And what happens if a Sinemeric-controlled robot suddenly needs servicing on the machine tool?
No problem. Since there is no separate robot controller, this service can be carried out directly by machine tool service personnel or by the system integrator. A robot manufacturer itself does not have to be commissioned directly.
Great. And could initial work preparation for the robot take place on the digital twin?
Yes, of course. In Run My Virtual Machine, some robot sample machines are included and you can try out robot programming with them directly.
Ah, perfect. You can get a trial version of the virtual machine free of charge via CNC for you.
Precisely. And as a small outlook, Sinumeric-controlled robots can not only perform loading and unloading processes, of course. They are also used, for example, in conventional manufacturing for drilling and milling large workpieces, or for large-format 3D printing in additive manufacturing. Sinumeric-controlled robots also impress with their path accuracy in technologies such as tape laying or non-destructive testing. As you can see, there is still a lot to show here.
Yeah, fascinating. I was particularly impressed by how easy it is to integrate a robot into the familiar Sinemeric environment without any additional programming languages or complicated controls. In any case, we'll continue to pursue this issue. Thanks for watching, and see you next time.